In the ever-evolving landscape of software development, efficiency and portability are paramount. Developers are constantly seeking innovative solutions to streamline their workflows and deploy applications seamlessly across different environments. Enter containerization, a transformative technology that has revolutionized the way we build, ship, and run software. At its core, containerization is a lightweight virtualization technique that allows developers to package applications and their dependencies into isolated units called containers. These containers are self-contained, portable, and independent of the underlying operating system, making them ideal for deployment in diverse environments, from development laptops to large-scale cloud infrastructures. Imagine a world where you can develop an application on your local machine, confident that it will run flawlessly on any other machine or server without compatibility issues. This is the power of containerization. By encapsulating all the necessary components within a container, developers can ensure consistent and predictable application behavior across different environments. The rise of containerization has been nothing short of remarkable, driven by its ability to simplify deployments, enhance resource utilization, and accelerate development cycles. In the following sections, we will delve deeper into the world of Docker, the most popular containerization platform, exploring its inner workings, benefits, and real-world applications. To fully grasp the significance of containerization, it's helpful to understand how it differs from traditional virtualization. While both technologies offer a degree of isolation and resource management, they approach these concepts from different angles. Traditional virtualization relies on a hypervisor, a software layer that sits on top of the physical hardware, to create multiple virtual machines. Each virtual machine runs its own operating system and applications, effectively simulating a complete computer system. While powerful, this approach can be resource-intensive, as each virtual machine requires its own operating system kernel and associated overhead. Containerization, on the other hand, takes a more lightweight approach. Instead of creating full-fledged virtual machines, containers share the host operating system kernel and isolate applications at the process level. This means that containers are much smaller and faster to start than virtual machines, requiring fewer resources and enabling greater efficiency. Think of it this way. Traditional virtualization is like building separate apartments in a building, each with its own kitchen, bathroom, and living space. Containerization is like renting out individual rooms in a shared house, where residents share common facilities like the kitchen and bathroom. Both approaches offer privacy and separation, but containerization is more efficient in terms of space and resource utilization. Docker has emerged as the de facto standard for containerization, providing a comprehensive platform for building, sharing, and running containerized applications. At the heart of Docker lie four key components: Docker Engine, Docker Images, Docker Hub, and Docker CLI. Docker Engine. The Docker Engine is the core runtime environment that powers Docker. It's responsible for creating, running, and managing containers. Think of it as the engine that drives the entire containerization process. Docker Images. Docker images are read-only templates that contain everything needed to run an application, including the code, libraries, dependencies, and runtime environment. They serve as the blueprints for creating containers. Docker Hub. Docker Hub is a cloud-based registry for Docker images. It acts as a central repository where developers can store, share, and download pre-built images, fostering collaboration and accelerating development workflows. Docker CLI. The Docker command line interface provides a set of commands for interacting with Docker Engine. It's the primary tool for building, running, and managing containers from the command line. Together, these components form a powerful ecosystem for containerization. Docker Engine provides the runtime environment, Docker Images package applications, Docker Hub facilitates image sharing, and Docker CLI enables command line control. Now that we have a basic understanding of Docker's core components, let's walk through the process of creating and running a simple Docker container. Step 1. Install Docker. The first step is to install Docker on your machine. Docker provides easy-to-follow installation instructions for various operating systems on its website. Step 2. Create a Docker file. A Docker file is a text file that contains instructions for building a Docker image. It specifies the base image, dependencies, commands to run, and other configurations. Step 3. Build the Docker image. Once you have a Docker file, you can build the Docker image using the command. This command reads the instructions from the Docker file and creates a new image. Step 4. Run the Docker container. With the Docker image built, you can run a container using the command. This command creates and starts a new container instance from the specified image. Let's illustrate this process with a simple example. Assume we want to create a Docker container that runs a basic web server using nginx. The Docker file would look something like this: from nginx latest copy index, html, usr, share, nginx, html. This Docker file instructs Docker to use the latest nginx image as the base image and copy the file from the current directory to the directory in the container. To build the image, we would run the following command. This command builds an image tagged using the Docker file in the current directory. Finally, to run the container, we would use. This command runs a container in detached mode, maps port 80 on the host machine to port 80 in the container, and uses the image. Congratulations! You have successfully created and run your first Docker container. Section 5. The Docker Advantage: Unlocking the benefits of containerization. Docker's popularity stems from the numerous benefits it brings to the table, transforming the way developers build, deploy, and manage applications. Let's explore some of the key advantages of using Docker. Docker containers are highly portable and can run on any machine or environment that has Docker Engine installed. This eliminates the "it works on my machine" problem and ensures consistent application behavior across different stages of the development lifecycle. Docker containers provide process-level isolation, meaning that applications running in different containers are isolated from each other and from the host operating system. This prevents dependency conflicts and enhances security. Docker containers are lightweight and share the host OS kernel, making them much more efficient than traditional virtual machines. This translates to faster startup times, reduced resource consumption, and improved performance. Docker makes it easy to scale applications horizontally by deploying multiple containers across a cluster of machines. This enables applications to handle increased traffic and load efficiently. Docker images can be versioned and tagged, allowing developers to track changes and roll back to previous versions if needed. This simplifies the process of managing application updates and deployments. These benefits have made Docker an indispensable tool for developers and organizations of all sizes, empowering them to build, ship, and run applications with greater speed, agility, and efficiency. Section 6. Docker in action: Real-world use cases and applications. Docker's versatility has led to its widespread adoption across various industries and use cases. Let's delve into some of the most common applications of Docker in modern environments. Docker is a natural fit for microservices architectures, where applications are decomposed into small, independent services that communicate with each other. Containers provide the ideal isolation and deployment mechanism for microservices. Docker enables developers to create consistent and reproducible development environments that mirror production environments. This eliminates environment-related inconsistencies and streamlines the development workflow. Docker integrates seamlessly with CI/CD pipelines, enabling automated building, testing, and deployment of applications. Containers provide a consistent and reliable environment for each stage of the pipeline. Docker containers are highly portable and can be deployed on various cloud platforms, including Amazon Web Services, AWS, Microsoft Azure, and Google Cloud Platform, GCP. This provides flexibility and avoids vendor lock-in. Docker can be used to modernize legacy applications by containerizing them and deploying them in modern environments. This extends the lifespan of legacy applications and eases the transition to newer technologies. These are just a few examples of how Docker is being used in real-world scenarios. Its versatility and benefits have made it an indispensable tool for organizations looking to streamline their development processes, enhance application portability, and embrace modern architectural patterns. Section 7. Embracing the future with Docker. Docker has undoubtedly revolutionized the way we build, ship, and run software, empowering developers with a powerful toolset for containerization. Its ability to simplify deployments, enhance resource utilization, and accelerate development cycles has made it an integral part of the modern software development landscape. As the containerization ecosystem continues to evolve, Docker remains at the forefront, driving innovation and pushing the boundaries of what's possible. With its active community, comprehensive documentation, and wide adoption, Docker is well-positioned to shape the future of software development. Whether you're a seasoned developer or just starting your journey into the world of containerization, Docker offers a wealth of opportunities to streamline your workflows, enhance your applications, and embrace the future of software development. Section 8. Resources for further exploration. This essay has provided a comprehensive overview of Docker containerization, but there's always more to learn and explore. Here are some valuable resources to deepen your understanding and embark on your Docker journey. https www.docker.com https hub docker.com. Containerization is the New Virtualization by Nigel Poulton. With its vast resources and supportive community, Docker empowers developers of all levels to harness the power of containerization and unlock a world of possibilities. So, dive in, experiment, and embrace the transformative potential of Docker.